Hey guys, let's keep working on this data wrangling in R. With this lecture, we're going to be going a little bit more into actually changing variables in R. We'll use the mutate function, some of these things, to add columns to our data frame that's already in R, and to be able to kind of start preliminary analysis or convert variables into more desirable ones for future analyses, etc. So let's get into it. All right. So to start here, we're going to do a new little subheading, and we're going to call this one Mutate. All right. So we're going to keep using this airplane data that we had, really easy data set to kind of work with here. So let's annotate our code. Always a good habit. What if you want to add new columns to your data frame? We have the mutate function for that. So first thing we're going to do, let's make a smaller data frame so we can see what we're doing. The data frame that we have for this my data is 19 variables, so it's very long, right? So let's use what we already learned. So we're going to say my data small, and we're going to say select, which we learned above, from my data, year through day. So we want the dates, and then we want to also include distance and air time. So we're going to run that. And so now we should have up here my data, let's see, where is it? My data small must be this one. Yep, my data small. We have the year, month, day, the distance, and the airtime. Perfect. For our mutate example, let's calculate the speed, not SEPID, speed of the flights. So to do that, we're going to use mutate. So we're going to mutate my data small, and we're going to say the speed equals the distance divided by the airtime, and then we're going to multiply that by 60, so we get it in hours as opposed to minutes, right? So let's run this code, and you see it automatically pops up here. So we have the year, the month, the day, the distance, the air time, so the amount of time spent in the air for the flight, and then the speed. And this would be in miles per hour, right? Because the distance is in miles. It doesn't say here, but it is. Because if that was feet, that would be a very short flight, right? Dad joke, yes. So here we go. So now let's look at, so remember, we just ran this in the console, but we didn't save it as a variable. So if we look at my data small again, it's not saved here. But what we can do is we can say my data small, and then put this mutate function in there. Oops, I didn't make that right. It's got to be an arrow. And so this will now save this into my data small. So if we look at my data small now, it saved it as speed as that last column there. Alternatively, what you could do, what if we wanted to create a new data frame with only your calculations, right? So say we want to do we ran a couple of calculations, not just the miles per hour, but also the fuel consumption or whatever else, hypothetical data columns, but we wanted to put that into a new data set, right? What we can do is we can use, I'll put up here, Transmute. We're only going to have an example of one here because we only did one conversion. We can do Transmute, and we're going to call this data frame airspeed. And we're going to do my data small. And we're going to say speed is the distance divided by the air time times 60. So this is the same conversion that we get to make miles per hour again. And we'll click run. And you see we have airspeed, and all it includes is our calculation of speed. So if we could also pipe in another and, we'll say speed 2 equals distance divided by air time, but we won't times it by 60. So if we run this, unexpected equal sign. Let's try this. Oh, nope. Let's try the and sign. Okay, let's try the comma. There we go. So it's a comma there. So so now we should have speed and speed 2. So this is miles per hour, and this is miles per minute. No, yes, miles per minute. So which miles per minute? Yeah, it's not like a great. This is just an example. It's not a great metric, right? So yeah, so Transmute allows you to use data from your master data set to kind of create another data frame or data set if you don't want them all into one single Excel file or data frame. Okay, so let's do a new heading here. Oops, and we'll call this one summarize and by group. These kind of go hand in hand because summarize is not super useful by itself, but it can be powerful. So we can use summarize to run a function on a data column to get a single return. So an example of this would be summarize my data, and we're going to use the delay, which was the amount of well, we're gonna actually create, this is gonna be the name of the column heading, excuse me. So we'll say the delay is the mean of the departure delay, and I'm gonna include this this call here that we haven't talked about, NARM. And we'll get a little bit more into it, but all this is doing, NARM, it stands for NA remove, NA being not applicable. So if there's missing data, it just gets rid of it. It doesn't try to compute it, because sometimes if you try to compute NA data, R doesn't like to do that. It becomes a problem. So if you run this, oops, I needed another. If it gives you this plus sign, it means you haven't closed off enough of your parentheses. So I'm gonna hit escape to get away from that plus sign, and then I'll click run again. And so the delay across all of my data, the average is 12.6 minute delay is average. So okay, that's somewhat useful, right? But not the most useful thing. So let's say, so we can see here that the average delay is about 12 minutes. But we gain additional value in summarize by pairing it with by group. Okay. So we're going to say by day is our new data frame, right? And we're going to use the group by. And we're going to use that function on our my data set, our master data set. And we're going to say year, month, day. And we'll then summarize by day our data frame that we just created. And we're going to say that the delay is what we did before, right? Is the mean of the departure delay, and that we're going to get rid of all the NAs. And I think I need another one of these. Okay, so first let's run this by day. And if we click on by day, or we can type head, you can see that we have everything factored out by the day, right? So we have, let's see. So it does it. So you're not really going to be able to see anything. It does it. It groups it, but behind the scenes, kind of. But if we were to run summarize, you see that we get the average by day, right? So the average delay of all the flights on January 1st, 2013 is 11.5. The average on the second is 13.9 minutes, etc. So we'll write, as you can see, you now have the delay by the days of the year. Okay. So, it can be useful, like, to be able to kind of get those averages summarized by itself. It's kind of, overly specific. You just get your one column summary, but if you break it up by your groups, then you can get much more informational data, or more valuable data. All right, let's make another section here. This one, missing data. So we're going to talk kind of at least put annotations for the missing data stuff. So what happens if we don't tell R what to do with the missing data? Question mark there. Okay, makes sense. So let's take this same code here and just remove the NA remove part, the NARM equals true. So we just have what's the mean of departure delay. So if we run it, we get all NAs. So what's happening is R is looking and says, I found a value that is NA, which means that R just doesn't know what it is. It doesn't automatically make it 0. It doesn't automatically make it 1. It doesn't automatically make it anything. And since we're averaging everything, anything that has an NA in it is automatically made a NA, because it can't give you a logical average if it has a value it doesn't know what it is. So if you say NARM, it says, okay, give me an average excluding all the ones that are a mystery to what their value is, right? And in this case, in this data set, all the NAs are flights that were canceled, right? Because the delay was indefinite, so infinity delay. So that's what happens if you don't get rid of the NAs. If you return a function that returns NA, it's probably because you had NAs in your input. So garbage in equals garbage out is some computational biologists I know say. But we can also, filter our data based on NAs, which in this data set was canceled flights. So say we wanted to look at canceled flights. Well, let's just pull out all the non-canceled flights. So we'll call it not canceled, and we'll say filter my data. We're always using our starting data set, and we'll say is NA for departure delay, and the opposite of is NA. So both of these are the opposite of is NA. So what this is saying is NA if, okay, let's look at let's find a good way to explain this. Okay, airspeed is NA airspeed. So what is NA does is it will go through, went through everything here. It'll go through and it is answering the question, is this value NA? And if it is not, if there's an actual number there, it'll say false. If there is an NA there, I saw one when I was scrolling, it will return true, right? So it's just a test. Is this value NA? Yes or no? Here's some truths. So line number 472, comma, whatever, 4072, something, something, something. These were NAs. And so it says, it answered the question, is NA? It says true. It is an NA, okay? So what we're gonna do is we're gonna put the opposite of that, right? So if we went all the not canceled flights, then we went all the ones that are not NA. So this is not NA. And then not arrival delay. Okay, so if we run this, not canceled. Oh, that works. Okay. So not canceled now. Where are we? Is all the flights that were not canceled. So if we look at the number here, we have 327,000 compared to 336,000 total flights. So we've weeded out all the canceled flights. Now, so here's my, here we go. Let's run summarize again on this data. So we should have delay equals mean. So now this, that we had an error before because we removed the NAs, because we've manually removed the NAs instead of using this NARM trick that we used up here, it should return the same thing, 12.6, right? So this was a way to remedy the NA problem above. But as you can see, it's much easier to just put in NARM equals true than to filter out your data set of all the canceled flights and then to run summary. So it's just kind of a shortcut, all right? Okay, so let's do another subheading here real quick. Counts. We can also count the number of variables that are NA in our data set. So the way that we do this is we say the sum. So count everything that is NA in my data, and then we'll do the column departure delay. So this should give us the number of the NAs in that column. And then we can also count the numbers that are not NA, so the rest of the values, right? So by doing that, easy, right? We just put the opposite tag there, the exclamation point in front of the not NA function. And now if we run this, it should be the rest, right? 328,521. That's just a quick way. It's a nice way that if you have like this data set, 300 some thousand rows of data, to be able to just kind of check, because you might get a raw data set and you're like, okay, I found this, I calculated the mean, and it's not what I expected. Well, you might want to check how many things are actually going into that calculation, because if only like 1% of your data is there to be calculated as part of the mean, you might get numbers that aren't what you expect in that regard. So lastly, we're going to do something called piping. This has to do with tibbles, and we're going to get more into what those are going forward. But with Tibble data sets, we'll say more on them soon. We can pipe results to get rid of the need to use the dollar signs that we just used above, right, to pull just that one column. So we can then summarize the number of flights by minutes delayed. All right, so an example for this, we're going to start by just calling my data, and then we're going to do %, greater than sign, %. And so this says, all right, for everything below, we're using my data. So we're going to say group by year, month, day. So we're saying, so as you noticed here in the group by, we never told it to look for my data. It's because we've saved the idea that we're using my data. We're saying, okay, in the following line, use my data. And so when group by is looking, it says, okay, I know to use my data because this told me that that's what we're starting with. And so we'll do it again. We're gonna group by the year, month, and the day, and then we're gonna summarize based on the mean. We're gonna call our column head the mean. That's what the first part is, and then we're gonna say mean of departure time, and then take our shortcut NARM equals true, because we don't want those NAs to show up, right? Okay, and if we run this last line, it should run all three of them because of the piping. Okay, so the error occurred in group 1 caused by error in mean. Object depart time not found. Interesting. I think we changed it to departure time, didn't we? Yep. See, this is where if you change your master file, you can get confused. So we're going to call this departure time because we used the rename function earlier to call it departure time. So there we go. So now we've taken my data, we've grouped it, and then summarized it all in one kind of small, nice readable chunk of code here, right? So we have the year, the month, the day, and then the average of the departure time for that day. So 23 minutes. Ooh, this is a little bit of a long one. So we're going to stop there right now. This has kind of been a crash course in how to mold and reshape and wrangle your data. Going forward, we're going to delve a little bit deeper. We're going to get into the tidyverse, Tidyverse, not the Spider-Verse, and learn more about these tibbles and things and ways to make data more moldable for your future analyses. So prepare yourselves for the tidyverse, and I will see you in the next one.